In this video, I'll be describing experiment 4, reactions of copper and percent yield. In this experiment, your goals will be to study the chemical reactions of the transition element copper, and then to describe these reactions using net ionic equations. There's going to be a lot of different oxidation reduction reactions that you'll see, so part of this will be for you to determine the oxidation number and the state of these different species. And there won't just be redox equations, there will also be redox reactions, I should say. There's also exchange reactions, metathesis, double replacement reactions, as well as decomposition. And it'll be up to you to recognize what kind of reaction is occurring as it's happening. And then finally, with this, you'll determine a percent recovery. In this experiment, we hope that you'll start to become very familiar with the idea of the complete and thorough transfer of materials. You're going to be doing a number of reactions in this experiment, and it's important that after every single step, all of the material makes it where it needs to. And the next, there's a lot of different chemicals that we'll be using. A number of them are quite corrosive, so it's also good to start practicing using these hazardous solutions and how to be safe in their use. We hope that with this you'll also gain the following knowledge. You should be able to predict the products of the reaction. You'll know what you start with. You'll know what you're adding, so you should be able to then predict what kind of reaction will occur and what the products will be. You'll use the observations that you see to help identify the products of the reaction that is happening. You'll then have to be able to understand the different properties of the products and how you utilize those for the purification. Sometimes they'll be soluble, sometimes not. Sometimes they react with different things, and that's how you can purify molecules that way. So we're going to consider the different properties of the different copper salts that you'll be making. And then finally, you'll have a better understanding of the basis of percent yield and what factors govern the recovery of a material as you do all of these reactions. So in this experiment, you'll begin with the elemental copper, and what you'll be doing is you'll be utilizing the properties of copper and their salts, not only for their reactions, but also for their purifications and then for their identification. So for example, copper is a solid, not soluble in water, has that very distinctive copper color, but its different salts won't all be the same. It won't all have the same color, they won't all be soluble, they won't all react identically, and you're going to take advantage of that in this experiment. We're going to convert copper to a variety of different salts. Each of these will have what we assume is 100% conversion. And what we'll also be hoping you ask yourself is, what is the driving force in this reaction? What causes that 100% conversion to occur? Because sometimes it could be a precipitate, you're forming a salt. Sometimes it could be making a gas, and this gas then escapes the system that helps to push the reaction forward. It could be the formation of a weak electrolyte that also helps push reactions forward. That can be the driving force. So consider that in every reaction that you do. And then consider what properties these salts have and how you'll take advantage of that for purification. And as I said, finally, what you'll do is you'll begin with copper, you'll do a number of reactions, and you'll end up back at elemental copper. And theoretically, you should have 100% yield. You should start with the same amount of copper, or you should end with that same amount of copper that you started with. But you'll use that to calculate the percent yield and find out how well everything reacted and how well you carried material from one flask to another. So while you're doing the experiment, you will, one, carry out the reactions as written down in your lab manual. You'll write detailed observations of each reaction because you'll use the different descriptions to understand what products were being made. You'll use those observations to help identify the reactants and products, and use that again to identify what type of reaction and to identify how to write the balanced equation for each reaction. The types that you'll see again are redox, oxidation reduction, the transfer of electrons from one material to another, metathesis, or changing partners, double replacement reactions, or decomposition, where a single molecule will break into two or more parts, usually under heat. Here is a table describing some of the different compounds that you can expect to see. I'm not going to read through this, but consider the fact that here's a bunch of different copper salts, and you can see that These have different properties, different colors. You'll be using different other reagents. So use these basic descriptions to help aid your observations and identify the products that you see. So here I pulled from this YouTube clip some different pictures of different steps of these reactions, and you can see at various stages there's wildly different looking colors and physical properties of what you're looking at. So you'll use those observations to help you understand and predict what products are being made at each step. And then finally, as we said, your goal is to get the highest percent yield that you can. You'll start and end with copper, and with no mass loss and perfect 100% conversion, perfect transfer of material, you should end up with 100% of the copper that you began with. It's almost certain that you won't get 100%, but it's a good practice to start using your hands well and being as careful as possible about, one, deciding when a reaction is finished, and two, making sure that you've completely transferred material from one flask to another. So to sort of walk through the general the procedure of this experiment, you'll start off getting copper turnings and put them into a weigh boat, and then put them into a pre-weighed beaker. Again, so you want to make sure that you get the mass of the copper that makes it into the reaction. Not the copper that's in the weigh boat, but the copper that makes it into the reaction. So you have a pre-weighed beaker. Off of the balance, you transfer the copper, and then afterwards get the mass of that beaker with the copper filings. Then at that point, you can make sure that you don't have too much. And if you do have too much, remember, you're not going to put it back in the original container. You'll put it in a separate waste container. The very first reaction uses nitric acid. Nitric acid is, this is also very concentrated nitric acid, so you have to be very careful. It's a pretty severe irritant and corrosive, so be careful. Your TA will help you in dispensing this, and this will be done in the hood to be sure that any noxious byproducts are contained in the fume hood. Next, after that, you're going to wait for that to finish, and there's some description in the lab manual that I wanted to help describe. So after you react your copper with nitric acid, you're going to also start heating up 50 milliliters of water in two different vessels. One in a 250 ml beaker, another in a 150 ml beaker. Once this reaction between the copper and the nitric acid is finished, you're going to pour the contents into the 250 ml beaker, and then you're going to use the water from this other beaker to rinse out that initial flask. Something I didn't quite hit hard enough. Remember, you're going to pre-weigh the beaker before you add the copper and the nitric acid. You'll also pre-weigh the beaker that you're going to be ending up pouring everything into. So remember to do that. The next step will be to use sodium hydroxide. And again, sodium hydroxide is very corrosive. You have to be careful to handle this with care. After that, the next step, again, is to heat this up. And we're going to try avoid using flames. We're going to be using some things that are flammable, and we don't like to use flammable things with fire. So use a hot plate to heat things up. And again, remember, treat these with care. They're going to be very hot. So use the hot hands, use tongs, whatever you need to move reaction vessels off of the hot plates. After it's reacted, remember, we're going to be decanting things. You have to be very careful not to lose any solid. This won't be quite the same as the zinc iodide, where it was pretty sticky and stuck to the sides. You're going to have some solids that are going to be much more free-flowing, and this is much more of a worry that you're going to lose solid in the decanting process. So be very slow, be very careful, and be very cautious you don't lose any material. It's better to leave some supernatant behind than to lose solid, because you'll be doing rinses, and it's okay if you leave some liquid behind, but definitely don't lose any solid. In another step, you'll be using sulfuric acid. This again is a very dangerous corrosive material, so we'll have the TA use it first. Be cautious, be careful, and we're going to handle this with extreme care as well. At another stage, you'll use methanol. You're going to use that repipette that we used before. So remember again that it's going to be set at 5 mils, so don't worry about changing the toggle on the repipette. Remember, lift it up and push down and it will dispense your methanol. We're going to avoid using flames, but that doesn't mean that methanol still isn't flammable with a hot plate. So just be careful about using methanol while using the hot plates. And then finally, once you're done, you'll clean up and put your copper that you produce into the solid waste. You're going to put the methanol away appropriately as well, and we're going to try to ensure that you don't put the copper and methanol or the zinc and methanol in the same container. We want to keep those separate. So be cautious again. We want to keep the liquid methanol in one container, the copper in another, and the zinc in another. Finally, it's important to remember the safety aspects of this lab. We're going to be heating things up. Some of these, as you may have seen, are going to be gas-forming reactions. So it's important to wear goggles. There's a lot of risks of things splattering, so we want to make sure those are protected. Nitric acid, sulfuric acid, sodium hydroxide, all of these are very caustic things. So you want to make sure you're wearing gloves and to try to avoid any skin contact with any of these acids and bases. You'll also wear a lab coat again to protect your skin and your clothing. We're going to be introducing a lot of different chemicals, a lot of different acids and bases, so it's very important that you're very sure what you're adding. Do not assume that this is the sulfuric acid. Do not assume that this is the zinc or something. Be sure to read the labels and don't add anything unless if you know what you're adding. And again, because we're going to be doing a lot of reactions with some kind of hazardous material, make sure that you're very clear on what the directions are before you start any single step. And finally, I wanted to show some of what you'll expect. This is a video from Dr. Corneli about the reaction of nitric acid with copper. So this is the first reaction that you'll do. You see that there's nitric acid, and there's a very large ball of copper. When that's put then into that fairly large Erlenmeyer, you'll see that adding that to the nitric acid, it reacts quite violently, and you can see that red-brown gas escaping from the top. So while this is happening, be sure in your notebooks, write down what you see, describe everything. Describe the bubbling, describe the color, describe whether it's a solid, a liquid, or a gas. And then after this, we'll show the next step once it's finished. You can see it slowly stopping. There's less and less gas being evolved. The next step then, adding the sodium hydroxide. Oh, sorry, this is just adding the water. You add the water and you can see that, again, significant change from where you started. So write down all your observations. Similarly, there's one more video we wanted to show about reacting a penny with nitric acid. Very similar reaction. In this one, you have kind of an older penny. This is from 1969. At that point, they were made entirely of copper, and you can do the same reaction mixing a penny with nitric acid. Again, you can see the reaction and then that production of that red-brown gas as it escapes from the solution. Okay, so with that, I hope that you're excited and ready for the lab. This is a very interesting experiment to see all the different types of reactions that can occur with copper. It's an experience to use all of these different types of reagents and get practice in their use. So I hope that you're excited, and we'll see you in the lab.